Okay, Assalamualaikum and very good day to you, sir. So today we're going to present our solid mechanics BMMM 2303, the assignment presentation. So the title is torsional loadings evaluation from actual structure. So as we can see here, this is a group project and the group members are first Mohammad Alif Haikal bin Azahari, second Mohammad Hafizin Arif bin Tajuddin, and third, myself, Mohammad Nabil bin Mohammad Khusaini. So we're going to start now. All right. Okay, so firstly, the objectives. So the objectives are first to draw details FPD from actual structure related problem. Second is to develop equilibrium equation from the FPD drawn. And thirdly, to analyze force members from the structure. All right. The next part, I'm going to hand over to my associates, Muhammad Alif Haikal. So, Alif, you can start now.
Okay, my name is Mohammad Alif Haikal bin Azahari. I will explain about theory about torsion force. Okay, torsion force is a twisting force that is applied on an object by twisting one end when the other is held in position or twisted in the opposite direction. In the field of solid mechanics, torsion is the twisting of an object due to an applied torque. Torsion is expressed in either the Pascal PA and SI unit for newtons per square meter, while torque is expressed in Newton meter Nm. Okay, for this assignment, we are asked to perform a torsional loading evaluations from an actual structure. And for that purpose, we have chosen a L range pipe as an item to be evaluated. L wrench is an equipment that is usually used together with socket to tighten and loosen nut. The wrench is made of chrome vanadium, a reasonably strong steel alloy. Okay, proceed next slide. Okay, the mechanical properties of chrome vanadium, Young tensile modulus is 190 GPa, Brinell hardness 270. Okay, for the Poisson's ratio 0.29. Okay, next part is fatigue strength 430 MPa. For the shear strength is 590 MPa. The UTS 940 MPa, and the YTS is 620 MPa. Okay, we are using the L range. The diameter is 2 cm. For the bar length is 30 cm. Okay, the also the handlebar length is 30 cm. Okay, for the theory for torsion calculation formula, the following formula can be used to solve any torsion situation that are forced to explain. Okay, according to the formula, where T is torque or twisting moment, Newton time meters. For J is a polar moment of inertia or polar section, and moment of error about shaft axis. T is a shear stress outer fiber. We are using PA or PSI unit. For R, radius of the shaft. Okay, for the next one is G for modulus of rigidity or shear modulus. We are using unit PA, and the theta angle of twist by using radius, and L is length of the shaft, meter or inch. Okay, I will pass to the next presenter, Mohammad Hafizin Arif, for the calculation.
Okay, my name is Mohammad Hafizin Arif, and now I will explain about the calculation of the structure. First of all, we will let the diameter of torsion bar approximately 2 cm. Length of torsion bar is 30 cm, and we will assume the force acting on the bar is 800 Newton. Also, since the material is chrome vanadium, the Young modulus is estimate of 190 gigapascal. Okay, next. First of all, we will calculating the speed using the formula of velocity equal to diameter divided by time. Then, we assume of average of human mass is 80 kg and times with gravity, and we will get around 800 Newton of force. Also, we can calculate the acceleration in circular motion, which equal to velocity power of 2 divided by radius. Next, we can continue to calculate the equation of equilibrium, where moment is equal to 0. And to calculate torque, we use T is equal to work force acting on the bar times with the length of torsion bar. Next, we calculate the area where diameter power of 2 is divided by 4. Also, we can calculate the polar moment of inertia, where J equal to pi times diameter power of 4 divided by 32. After that, the we can calculate the value of yield strength, where stress is equal to force divided by area. Next, we calculate the maximum of elongation for the shaft to break, where stress is equal to force acting on torsion and times with the length of torsion bar divided by area times with the Young modulus. After that, by using those data, we can continue to calculate the twist angle, where angle of twist is equal to torque times with length and divide by polar moment of inertia times with modulus of rigid body. Also, we can calculate the allowable working force by assume half of the yield strength equal to torque times radius divided by polar moment of inertia. And lastly, for the factor of safety is equal to assumption of stress field divided by assumption of stress allowed, and the value we get for the safety is 2. That's all from me. Continue to Mohammad Nabil.
All right. For the final part is the analysis and discussion. So as we know, or I'm going to tell it in this analysis and discussion, chrome vanadium is a special kind of steel formed by combining different alloy. So the substance standardized as ASTM A231 in industrial nomenclature is most often used in high stress applications. Physical, chemical, and mechanical properties of chrome vanadium give it a specific load tolerance, corrosion resistance, hardness, and behavioral characteristics. So to keep it simple, it is very hard and durable metal. So from the conducted calculations, the results show that this material possesses a considerably high value of yield strength, angle of twist, and working allowable force. Due to the nature of the material, it will take a considerably high amount of force required to break the material, and it can be safely assumed that under normal conditions does not easily fail by pure human strength. And the factor of safety of this material is also within the allowable value for the equipment's intended use. So that's all from us. Okay, thank you very much. So the end.